Now let's do our line integral in spherical coordinates the same way we did our line integral in rectangular and cylindrical coordinates. Let's suppose that this is our charge that is going to have a 4 coulombs per meter charge distribution, and it's going from phi equals 0 to phi equals 90. And where is it in theta? It's down here on the xy plane, so theta is equal to 90 degrees. Now we want to be able to integrate this to find the total charge perhaps that's along this line, so we know that we're going to be doing a single line integral. We now need to define what changes. Look at this particular arc. Does r change? dr? No, dr doesn't change. dr is 0. How about phi? Does phi change? Yes, we can see that phi goes from 0 to 90 degrees, so d phi is not equal to 0. How about theta? Does theta change? Theta is always equal to 90 degrees in this case, so theta is equal to 0. So let's come to our dl term, and let's decide which of these pieces we need to keep. In this arc, dr is always equal to 0, d theta is always equal to 0, and phi is the only thing that's changing. So that's the dl term that I'm going to put here. R sine of theta d phi. That is my dl term. Notice that it's going to be scalar because my function is scalar. Otherwise, I would use this component and there would be a dot or something of that nature. Over here, I'm going to put in my function, 4 coulombs per meter, and let's see, the thing that was varying was phi, and it goes from 0 to pi by 4. Now I need to look at these other variables such as r, and let's say that this radius is 1 meter, and then I need to look at theta, which is 90 degrees, right here. So sine of 90 degrees is 1, r is 1 meter, so I'm just going to integrate this as a function of phi. 4 coulombs per meter, r was 1, sine of theta was 1, phi goes from 0 to pi by 4. Now what would have happened if I had had a different shape instead? What if instead of being that arc, what if I had been this arc? In that case, dr is still equal to 0, d phi is equal to 0, and d theta is not equal to 0. So this term would have gone to 0, this term would have gone to 0, and here's the integration that I would have been doing with r d theta here. R is 1 meter, 4 coulombs per meter, and theta goes from 0 to pi by 4. So you can see that what I do is I just find the values that are not changing, and that is going to be the line integral that I use.